Good evening, students. Uh, Now let us explore the temperature control system. Okay, followed by the level control system. Okay, so if you take a temperature control system, it is very clear that you are going to have a heat as a medium, and you are going to measure the temperature as a parameter. Okay, so for exploring about the temperature control system, let us take a thermal system. Okay, and it is very clear that thermal system always involve the transfer of heat from one substance to another substance. Okay, and here also similar to a level control system, here you will have a two parameters. One is called as a thermal resistance, another one is called as a thermal capacitance. Okay. um, Okay, so here if you take a heat, okay, so the heat can be represented in terms of three ways. One is a conduction, another one is a convection, another one is a radiation. Okay, here we consider only the conduction and convection. That is radiation we are not going to consider because the parameter we are going to measure is model is temperature. Okay, so if we consider the radiation, there will be a loss of heat, and we are not at all going to concentrate on the loss of heat. Okay, we are going to concentrate only either on the conduction or convection heat transfer. Okay, so here they represent the flow rate, heat flow rate as K into delta theta. Okay, K is a coefficient and theta is represented as a temperature. Okay, and here it is represented, K is a coefficient. For conduction it is represented as Ka by del x, and for convection it is represented as H into A. Okay, so as I said, similar to a laminar flow resistance and laminar flow capacitance, here we have a thermal capacitance and thermal resistance. Let us define what is this capacitance and resistance. Resistance is nothing but the change in the temperature difference to change in the heat flow rate. Okay, so already we know very well for a level control system, just compare and explore. Okay, so for a level control system, there is a change in the level difference to the change in the flow rate. Okay, so here it is a change in the temperature difference to the change in the heat flow rate. Okay, and similarly if you take a thermal capacitance, here there is a change in the heat stored to the change in the temperature. Okay, so these are the parameters which we are going to concentrate when you want to model the thermal system. Okay, coming to the modeling of the thermal system, similar to a level control system, here let us represent the theta as a temperature. Okay, so steady state temperature of the inflowing liquid and steady state temperature of outflowing liquid. Let us take G as a steady state liquid flow rate, M is a mass of liquid in the tank, C is a specific heat of the liquid, R is a thermal resistance, C is a thermal capacitance, and H is nothing but the steady state heat transfer. Okay, so this is a block diagram representing the heater, and you have a mixer where the cold liquid is converted into a hot liquid. Okay, coming to the mass balance equation governing the, so here you call this as a heat balance equation governing the thermal system. So it is represented as C into d theta by dt is equal to the same you can represent as Qi minus Q naught. Okay, so already you represented what is this Q naught. Q naught is nothing but H by sorry, R is equal to H by Q. So from this you can write Q naught is equal to H by R. Okay, so same. Okay, so C into d theta by dt is equal to Qi minus Q naught is H by R. So just sorry, yeah, it is not H, it is theta by R. I'm sorry, because here you represent the thermal system. Okay, so here when you take LCM, you will get RC into d theta by dt plus theta is equal to R into HI. So similar to the liquid level control system, we are going to arrive the transfer function of the particular system. The transfer function of a particular system can be arrived with the help of a Laplace transform. So Laplace transform of this particular system. So you will get the output as theta naught divided by theta I, which is equal to 1 by tau s plus 1. Okay. So this is nothing but your mathematical model of the respective thermal process. Okay. So the same equation where tau is a time constant of the particular system. Okay. Thank you, students.